form the final sentence. In the arithmetic expression, do you have integer in the final answer? In the final sentence? We won't have, right? So we don't write integer is our final sentence. What we will do is, we will replace the integer with digit. Okay, so it depends on what are the digits we have. Then this one is the example of the digit. Either you replace the digit with a 0 or 1 or 2 and until 9. So all these are the example of the digit. Okay. So here the terminal symbol you can write. Follow this example. So the terminal symbol are 0 to 9. And the non-terminal you have integer and digit. We use for the substitution just now is a direct derivability, meaning that if you substitute the x with y, then you will say that y is direct derivable from x, which means that your x can be substituted with y. So this is only one, either it can be one step only. You get x substitute with y, one step only. So this one we call as direct derivable. Direct derivable. Okay, so the symbol you can use like this. The arrow with the two lines. So if you refer to the previous example, so what is the example? We can say the word we can get directly from one step only. Example, drives, you can substitute from this verb, right? And then you substitute it carefully for the adverb. Okay? So these ones are all the direct derivatives. Put any example you refer to this one, the example just now. So, okay, you can say drives, substitute from you can put verb, adverb, directly derivable from where? Verb, adverb. How do we get verb, adverb? One step substitution from, refer to the example just now. Yes, this one, verb, adverb, you get from predicate, right? Okay, so here is direct derivable from predicate. What else? Example, direct derivable. Put the word for key, you get from where? Yes. Now, you can put other example also. Maybe you can say carefully is directly derivable from verb and so on. Okay? So these are the one-step substitution. For example here, if you have the production given like this, AB, you can substitute with BCD. So if they give you BABE, meaning that we can replace this with the AB, we can replace with BCD. So we will get, what do we get for this string here? BABE can become AB. Yeah, AB replaced with BCD, so we will have B, B, C. this is only one step substitution. If let's say we have more than one, the substitution, let's say the sentence he drives carefully from sentence only. From the starting point sentence, how do you get he drives carefully? You need a few steps of substitution, right? So in that case, we will call it as a transitive closure, where we will only write the arrow just now and then together with the infinity sign. Meaning that this substitution will be more than one step. Okay, so this is a transitive closure that this term also you have learned before, right? Transitive closure. Okay, so this one in the substitution here, it will mean that we will substitute it by using more than one step. So again, using the same example, how do we show that we need to have more than one step in order to get the final sentence? He drives carefully. So same also, write one more time. You can write already, right? So many times already I show you. Sentence, replace with. We do directly derivable for each substitution. So sentence can replace with what? The substitution for sentence split to two parts, noun and predicate. Then after that, one substitution each time. Substitute the noun first with noun with he, right? And then this one, predicate can substitute with verb and verb. Okay? Verb substitute with drive. This one you can write what? Adverb first, we substitute one. And the last one is he drives carefully. The sentence we can form from all the set S, the words inside the set S, and after that we can also get the sentence from the starting point, which is the word sentence. You can get to this final sentence. Then this one we call it as a properly constructed sentence, because the verb and the all this substitution, it is correct. You substitute one by one, right? So this one is called a properly constructed sentence. As long as your word form from the sentence. Or we can say that it is a syntactically correct sentence. The syntax is correct. So conclusion is, if we have a language, you must have four components. The first is the V, S, V0, and also the substitution sign, right? So next time when we come to the language part, we will just write like this. V, you need to know what is V already. S, what are the words inside the set S. V0, which is the starting point, and this is a production relation, which is the substitution symbol. Okay, so all these are the components to get a correct grammar. So this one we will always write it in the LG, which means that it is a language of the grammar. So we will write it as this, the W, which are the words get from the set S, and the V0 after a few substitution, you will get to the final sentence, which is the W. Okay? Now, one more time for this, how do we get a properly constructed sentences in LG? So here we have he drives carefully belongs to the LG, meaning that if you refer to example 5 again, he drives carefully is one of the correct sentence. Of course, you can have other sentences also. What are the other sentences we can have if you refer to example 5? This one. Besides, he drives carefully. What else are the sentences that we can have? Huh? She drives carefully. What else? He runs slowly. She runs slowly. Any others? Can we say he runs frequently? Yes? Also acceptable, right? Okay. All together, how many sentences we can form? How many sentences? If you draw the tree from the one that I showed you just now, then you can see easily here. This is now predicate. How many sentences it can form? Now you can have he or she. Predicate can have verb and adverb. Verb can have run or drive. Any more? And then adverb can have yes, slowly, carefully, frequently. So altogether, how many possible sentences we can have? Look from the tree diagram, will be easier, right? Give me the answer. How many? 12. Agree? How do we get 12? Here you can have 2 choices. Here you have another 2 for the verb. And for the adverb you have 3, right? So 2 times 2 times 3. Altogether we will get 12. So you can form 12 different sentences from here, from this example. Okay, up to here, any question you want to ask? So that is to tell you how is the properly constructed sentences come from the starting point until the element from set S. Okay. next one, you have these types of grammar. So for the types of grammars here, we can divide them to 4. Okay, so the first one is type 0 until type 3. So we have type 0 to type 3. Now, what are the difference between each of these? The first type 0 means the production that we will do have no restriction, meaning that you already know what is terminal symbol and what is non-terminal, right? What are the terminal symbols just now? The word we use to form the final sentence, correct? And the non-terminal are the words that we don't use to form the final sentence. So now we will only use the symbol or variable to show all this. We don't use the word anymore. So you have 4 components here, B, S, B0, and substitution. When I write the non-terminal, I will put with a capital letter, which means, for example, I will have A, B. I can replace it with A, B, B, A. Anything I replace for the type 0 will be considered correct, because for type 0 there is no restriction for the left hand side and the right side substitution. You can put anything, whether it is a non-terminal or it is a terminal combination for the left and right, also no problem. Okay, so you can write anything here as your example. The variable I write here, when it is a capital, it will represent a non-terminal symbol, and if it is a small letter, it will represent terminal symbol. Remember this, huh? So another example you can write as B, C, A, B. I replace it with A, C, B, B, C. So this is the example of no restriction substitution, which is the type 0. Okay? Now, the second type is type 1. So here, a little bit of constraint we have is the left hand side, the string that we have, it should be either less than or equal to the length of the string at the right hand side. So for example, if at the left here I have A, B, A, this is a string, combination of terminal and non-terminal also. When I substitute this, I can write it with A, B, A, B, B. This is also the combination of terminal and non-terminal, but now you can see that the string here is longer than the left side. The substitution one, which is at the right, it should be longer or the same length with the left hand side. It can be like this, B, A, B. You substitute with B, A, A. No problem, because they have the same length. Terminal or non-terminal, no restriction here. So it is still can be the combination of the two, whether it is terminal combined with non-terminal, terminal only, or non-terminal only. Okay? This is type 1, eh? Now, type 2. Type 2, the constraint is, at the left hand side here, there will only have a single non-terminal symbol. Single non-terminal means I can only have A at the left hand side. At the right side, it can have a terminal and non-terminal combination. So I can write A, B, A, B. The constraint here is the left side, you can only have one single non-terminal. At the right hand side, you can have either terminal, non-terminal combination. Okay, so this is type 2. Another example, you can put like this, B, capital letter, non-terminal, and the right side you can replace it with A, B, 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 and so on. Example, huh? Now, another one, type 3. The constraint will be more and more already. Type 3 is still the same at the left, which is one single non-terminal. But when you come to the right, the constraint now is you can only have at most one non-terminal. And the non-terminal must be at the most right side in your string. For example, at the left, I have a single non-terminal. At the right, I can have at most one non-terminal, but this non-terminal must be at the most right. You cannot write this capital A at the left-hand side of the small letter. If you write like this, then this is not the type 3. Understand? So here, we will not write like this in the type 3 grammar. We will put the non-terminal at the most right. And the number of non-terminal is at most 1, so I can write it like this. Without non-terminal. One single non-terminal at the left, at the right, I have no non-terminal because they say at most 1. At most 1 can be 0, right? So if you have none, then just put all terminal. So all these, it will apply to type 0 to type 3. And if you notice just now what I have said, you will know that the type 0 actually it is also can be said, you see, if I say that this is type 2, or if I say that this is type 3, can I say this is type 2 as well? Yes or no? Can I say this example is type 2 also? Yes, right?
Yes.
Because type 2 says that the left-hand side you must have one non-terminal, which I have it here, and the right-hand side they say that no restriction. So no restriction means I can write like this also at my right side. So this one can also be a type 2 grammar. Okay? Now, if this is a type 2 grammar, can you say that this is a type 1 also? Remember what is type 1 just now? The left-hand side, the string must be less than or the same with the right side string, isn't it? So now, you can see that the left-hand side here, the length is less than or equal to the right. Correct, huh? So even I say this is a type 2, but actually I can say this is type 1 also. Right? Then, if I say this is type 1, this is type 1, can I say this is type 0? Type 0, no restriction. So if this is type 1, I can say this is also type 0, right? Okay. The relation that we can see here is type 0 actually is a subset to type 1, which type 1 here will be the subset to type 2, and the type 2 will be the subset to type 3. Right? Because when I say this is type 3 means that I can say it is type 2, it is type 1, and it is type 0 also. Right? But if I say that this is type 2, it is not necessarily be type 3. So in that case, the subset here will apply in the diagram like this. You can draw a subset like the Venn diagram. Just draw the Venn diagram and then you put the subset inside. So the smallest one will be the type which one is a subset to which one? Zero. If it is type 0, it can be type 1, right? Okay, 0. And then this one can be type 1 inside here, and here is type 2. Okay, and inside here will be a type 3. So if it is type 3, you can say that this is 0 or 1 or 2 also. So the constraint for type 3 will be the MOS. Okay, MOS constraint for type 3. So if it is inside type 0, then it can be type 0, it can be, if it is type 1, you can say that it is type 0 also. But when they ask you to determine which type of grammar, you must write the most accurate one. If it is type 2, don't write type 0, because if like that, then every question also you write type 0, then no different already, right? So in that case, when they ask to determine the type of grammar, you must write the most accurate type. If it is type 2, write type 2. Don't write type 1, type 0. Understand? Okay, any question until here? Can follow or not? Can? Until here, can follow? Can I? Okay, so I continue to another part a little bit more. So we continue to this one, the BMMS notation. What is this means? Actually, this is a short form of the name of this vectors noun form. These two persons combined together to get this notation. When we write the BMMS notation, the substitution, the sign, just now the substitution or the production relation, we use the arrow, isn't it? Like this, right? The arrow. But now, in the BMMS notation, we will write it with a 4 dot and 1 equal sign. This means the substitution symbol. When they ask for the BMMS notation, you need to write like this. Okay? And then, for the non-terminal symbol, just now I say you will use a capital letter, right? But for this BMMS notation, if it is a non-terminal, we will put it in the bracket like this. So for example, B0 is a non-terminal. Then I put bracket B0. If B1 is a non-terminal, then I put a bracket B1. So when I see this bracket, then I will know that, oh, B1 is a non-terminal symbol. Okay? And if it is a terminal symbol, then we no need to put anything, no need to put any bracket. Just write it using a small letter. This is terminal in the BMMS notation. Okay? Bracket is non-terminal. And when we have alternative to the substitution, just now like you can substitute the verb with runs or drives, then in that case, we have alternative. Okay, you can put like this. Run, this one is substitution. This is a verb. You can substitute with run or drive. So alternative, put a straight line in between. This is alternative. You substitute the verb with either runs or drives under BMMS notation. Okay? So we try to write this production relation again in example 5. using the BMMS notation. So we will start with the word sentence, which is a non-terminal. So put it in a bracket, and then substitute with, just now, sentence substitute with noun, and then predicate. Because these are all the non-terminal, so we put them in the bracket. Then after that, we will substitute the noun, right? We can substitute noun with he or she. Put the alternative noun. Then predicate. Substitution. False, verb, one equal. So predicate we can substitute with verb, non-terminal also, and then adverb. Okay. After that, the verb you can substitute with right or right, and adverb substitute with carefully, slowly, slowly, or frequently. So this is the BMMS notation. So everything that we have for the substitution just now, you already have the example how to get the derivation tree from the substitution step by step. I show you the tree, right, using start from the sentence. So this one also, if you put it in the form of BMMS notation, the difference you need to take note here, the sentence bracket with non-terminal like this. Remember to put if they ask for BMMS, you must put like this. If you don't put the bracket, that means this is not the BMMS notation already. Okay? Then it will be wrong what you write. And the substitution, don't put the arrow with the line like this anymore. This one is for the normal substitution. If BMMS notation, then you need to put like this. The 4 dot with 1 equal. Okay? And for alternative, it is still the same, where you put the line to separate it. But for this sentence, when you substitute with noun predicate, this is not alternative. So you cannot put a line in between. You just put continuous. Okay? Same also for predicate, if you want to substitute with verb, adverb, right? This is also not alternative. So we cannot put a slash, a line here. Only when there is alternative like this verb, you can substitute with drive or runs, and then only you put a straight line in between. Okay? So the terminal symbol here, he, she, drives, runs, and all these carefully, slowly, frequently. All these terminal symbol we just write out without any bracket for this. Then when you see like this, you will know, even I use the variable, then you will know that, oh, this is a terminal symbol. Okay? So this is for BMMS notation. Any other question? Now, the example for this one, I will use the tree diagram. So they are related, actually, the chapter 1 that you have learned. In this chapter, we also have tree diagram, but the tree diagram that we learn is the substitution. So we will get the starting point, like the sentence, how do we substitute step by step until we get the final sentence. That is the derivation tree for chapter 2. In the following example, I will show how to get the derivation tree for all these substitution given. Okay, so in this case, we will only have the variable. We don't have the words anymore. So we will only look at these 4 components here and all the symbol given in the set B and the set S. So you need to know already what are the meaning in the set S, what are the meaning the element in set B, and so on. That's why just now I explained all that first. Okay, so in the following part, I won't tell you again what is the difference between set B and set S. You know the difference already, right? Anyone still don't know? What is the difference between set B and set S? What are the elements inside the set B that the set S don't have? Class? This one is continuous one. Up. The V0. This one is V0. So W and V0. What do we call this? What symbol is this? Terminal or non-terminal? Non-terminal, right? Okay, so that is the difference between the set B and set S. Okay, when I say what are the elements inside the set B but not inside the set S, then you should know V0 and W already. That is the element inside B but not inside S, meaning that in your final sentence that you form, you cannot have V0 and W exist in your final sentence. Okay, you can only have A, B, and C. So all these you must substitute it with A, B, and C. Follow whatever given here in the BMMS notation. Okay, so we will look at the example next week. Then I will explain to you how to get all these using the tree diagram also.